Breaking news! Abu Dhabi's hidden urban structure revealed. This research uncovers the spatial logic shaping how the city moves and functions. My name is Layla Hassanin, and this project is titled The Urban Space of Abu Dhabi, a Space Syntax Analysis. This research was developed as a part of the Ladders Grant, a collaboration between Abu Dhabi University and Qatar University, in collaboration with Dr. Mark Major, Dr. Hamid Al-Janahi, and the students' research team. In this study, I explore how street networks, block patterns, and spatial configuration influence movement and urban experience.
Before conducting this research, it was important to understand what has been already studied about Abu Dhabi's urban structure. Existing research on Gulf cities show that many modern developments are influenced by Western planning models, which prioritize large blocks, hierarchical road systems, and vehicular movement. At the same time, traditional urban areas, especially in Arab cities, characterized by smaller blocks, dense street network, and pedestrian-oriented environments that support social interaction. However, when it comes to specifically Abu Dhabi, there is still a noticeable gap in research. Most studies either focus on general urban growth or apply space syntax without fully connecting the results to everyday urban experience. This research aims to bridge that gap by combining quantitative spatial analysis with a more interpretive understanding of how people actually move through the city. In that sense, this project doesn't just analyze the city, it explains how its structure is experienced.
Over the past few decades, Abu Dhabi has transformed from a small coastal settlement into a major metropolitan city. This rapid growth has created two very different urban conditions: a dense walkable downtown core and a car-oriented peripheral districts with larger blocks and wider roads. To analyze this, we used space syntax methodology.
To improve the accuracy of the analysis, one connected streets, isolated segments that do not basically contribute to the continuous movement, were removed. This ensured that the final dataset reflects meaningful urban connections rather than fragmented paths. The analysis was conducted using Depth Map X, as I said, a tool specifically developed for space syntax studies.
An axial map of Abu Dhabi was created using Illustrator, mapping over 28,000 street segments across the city. Then, key spatial measurements was analyzed, such as connectivity and integration, to better understand movement patterns.
This figure presents the hierarchy of movement and integration across Abu Dhabi using color-coded ranges. Highly integrated streets and major movement corridors are concentrated in the downtown core, shown in red and yellow, indicating areas of high accessibility and activity. As the city extends outward, integration decreases, with larger block sizes and more hierarchical road networks in suburban areas and industrial areas. The map highlights a clear center-to-periphery structure where central areas support pedestrian movement, while peripheral zones rely on larger-scale connectivity.
The results show clear differences between central and peripheral areas. Downtown Abu Dhabi is made out of smaller blocks and shorter streets, which support walkability and social interaction. In contrast, peripheral areas have larger blocks and longer streets, and are mainly designed for vehicles. The analysis also shows that the highest levels of integration are concentrated in downtown Abu Dhabi, making it the most accessible part of the city. Meanwhile, peripheral areas have lower connectivity, with movement focused along major roads and highways. This creates a center-to-edge structure where accessibility gradually decreases as we move outward from the city center. These findings highlight an important challenge in urban planning: how to balance efficiency with human-scale design. While modern districts improve mobility, they often reduce walkability and limit social interactions. This research shows that spatial configuration plays a major role in shaping urban life. By applying space syntax analysis, planners can design cities that are more connected, walkable, and sustainable. Understanding the city's hidden structure is the first step towards designing better urban spaces for the future.